Greetings, Calc 2 students. This video is a short introduction to differential equations, and that corresponds to Chapter 9 in our textbook. So what I want to do is talk about first, what is a differential equation? Secondly, why do we need them, or how do we use differential equations? Third, how do we solve differential equations? And fourth, if we have a solution, how do we know that we've actually found a solution to our differential equation? So first of all, what is a differential equation? Well, a differential equation is an equation that has a derivative in it. So remember, one notation for a derivative would be dy dx. So dy dx is in the equation. So that's equal to, well, I'm just going to say math over here. So our derivative is equal to some other sort of math. That's our differential equation. Also remember that there are multiple notations for a derivative. So dy dx, for example, is equal to y prime. We use that prime notation often to mean dy dx. But we could also have other things. As it turns out, we could have a function named x, and that's equal to a rule that has a t in it. So this would be x as a function of t equals something. Let's say like t squared. So then we would have dx over dt. So sometimes our differential equations have x's in them because we've named the function x. Also, as a note, remember that we have the function, and then we have the first derivative, and then we have the second derivative, and then we have the third derivative. But remember, when we go to the fourth derivative in this notation, we use a 4, but inside the parentheses. And so beyond third, we usually use the nth derivative inside the parentheses. Those are notations that we generally use. Secondly, why do we need differential equations? Well, differential equations are particularly useful for modeling. Often, when we are trying to solve a real-life example or a real-life situation, our observations, our measurement are being taken, but what we can observe and what we can measure is a rate of change. So we measure a rate of change. And remember that a rate of change is a derivative. Let's say that we were modeling a population of people who were getting some sort of illness. Well, I could have the situation that each day the population of people who were being infected was a constant. So this would be a constant rate of change. So dy dx is equal to some constant. Or maybe I'm seeing a population where the rate of infection seems to be growing exponentially. So this would be dy dx equals some constant raised to a variable. And so I can observe the rate of change. I can observe how things are measured as they're changing. And from that, I can build a model. In fact, we're quite used to this, right? So you probably already learned about exponential growth and exponential decay. Well, as it turns out, exponential growth and exponential decay are the formulas that we've talked about in previous classes and learned come from the observation of a differential equation. Another one is Newton's law of cooling. Now that's a formula that we have memorized, but Newton's law of cooling actually comes from an observation of a differential equation. So differential equations can be very powerful in modeling real-life examples and then solving to find the function that drives these real-life models. Third, How do we solve differential equations? Well, here's the thing. Solving differential equations is hard. In fact, it's very hard. Fortunately, we know how to solve some of them. We know how to solve very few of them. We know how to solve not necessarily the simple differential equations, but there are certain families of differential equations that we know how to solve. You can take a course as an undergraduate in just differential equations and solving some of them that we know how to solve. You can take a graduate level math course in differential equations and solve some differential equations. But the amount of differential equations that we know how to solve compared to the number of differential equations that exist is very, 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 very small. So solving differential equations are hard. Fortunately, we know how to solve some of them. Fortunately, we know how to use some clever algebra tricks sometimes to solve some of them. But most differential equations we don't know how to solve. In fact, if we knew how to solve more of them, we could advance our knowledge of science and technology extremely rapidly. But we just don't know how to solve most of them. This is something that people, mathematicians, physicists, and others work on quite readily, is solving more advanced differential equations. And when we do solve them, we advance technology and other fields of math and physics. Number 4, how do we know that we have found a solution to our differential equation? Well, as it turns out, we know that we found a solution when it works. So, does it work? The fancy name for this is, does our solution satisfy the original differential equation? So, for example, is y of x, the function, equal cosine of x, a solution to the differential equation y second derivative plus y equals 0? So this is a differential equation, and it's a differential equation because it has a second derivative in it. Is y of x equals cosine of x a solution to this differential equation? So what I need to do is plug in my solution and see if it works. Well, I already have y equals cosine of x. That I can plug in to y, no problem. So then I just need to find the second derivative. So the first derivative is equal to minus sine of x. And then the second derivative would be equal to minus cosine of x. So now I can plug in the second derivative in for the second derivative. So when I write this all out, I get y second derivative plus y. Well, that's equal to minus cosine of x plus cosine of x. So I plugged in minus cosine of x for the second derivative, and I plugged in y equals cosine of x in for y. And sure enough, when I simplify that, I got minus cosine plus a cosine that in fact is equal to 0. So yes, y of x equals cosine of x is a solution. So proving that I have a solution that satisfies my differential equation is actually the easy part. I just plug it in and see if it works. Finding that solution can be quite difficult. However, there are some techniques that help us find solutions to some differential equations. Okay, good luck on Chapter 9. I hope this video is a good introduction into what differential equations are and how we use them.